This is lecture 5 on chapter 3 torsion, and today in this lecture 5 we will see this numerical about torsion. Numerical is a hollow circular of 200 mm external diameter. External diameter is 200 mm and thickness of metal is 20 mm and it's rotating at 180 rpm. The angle of twist of 3 meter length was found to be 0.7 degree. That means length of this metal is 3 meter. External diameter capital D, that's 200 mm. Thickness, and this is hollow circle. That means here thickness of this metal is 20 mm. This H part is rigid part and thickness of that H portion is 20 mm. Small t 20 mm. Rotating at 180 rpm. That means this n is equal to 180 rpm. Because this n, we need this n in for calculation of this power transmitted. So angle of twist theta is 0.7 degree, and in numerical they have given us G is equal to 80 into 10 raised to 3 MPa, and we have to find power transmitted. That means this P, and second maximum shear stress induced in the material, tau man theta. So this is data and this is problem statement. So for solving this numerical, first we have to find inner diameter, second polar moment of inertia, third power transmitted, and fourth maximum shear stress. Inner diameter small d is equal to capital D. This is capital D 200 mm and this thickness is 20 mm, and thickness is on top side also and bottom side also. That means 200 minus 2 into thickness is this small d. Small d is equal to this capital D minus 2 into this thickness. Capital D is 200 mm minus 2 into small t is 20 mm. (160 mm is inner diameter. Second, for hollow circular metal, polar moment of inertia formula. Capital J is equal to pi by 32 into d raised to 4 minus small d raised to 4. Capital D is 200 and small d 160. So this polar moment of inertia is 92.74 into 10 raised to 6. 200 raised to 4 minus 160 raised to 4 and multiply by pi divided by 32. 92.74 into 10 raised to 6. Third, we will find twisting moment by using torsion formula. And torsion formula is T by J is equal to G theta by L is equal to tau by R. We will find this twisting moment. We have this J, we have this G, we have theta and we have L. So use this first two equations. T by J is equal to G theta by L and T is equal to G theta by L multiplied by J, and G is 80 into 10 raised to 3 MPa and theta is 0.7 degree. That means 0.7 into pi by 180 radian and multiply by J is polar moment of inertia is 92.74 into 10 raised to 6. And divided by L, length of that metal is 3 meter. That means 3000 mm. T is equal to 80 into 10 raised to 3 multiplied by 0.7 multiplied by pi multiplied by 92.74 into 10 raised to 6 divided by 3000 into 180 is the unit. This is in MPa, that means Newton per mm square. This is in mm raised to 4, that means this mm square get cancelled. This is mm Newton, this is mm square, this length is in mm, so unit is Newton mm. 30.2208 multiplied by 10 raised to 6 Newton mm, and Newton meter value is 30.2208 into 10 raised to 3 Newton meter. Next step is to find power transmitted. Formula for power transmitted is 2 pi nt upon 60. 2 pi nt upon 60 is 2 pi nt upon 60 into 10 raised to 6 Newton per meter. 2 pi nt upon 60 is 2 pi nt upon 60 into 10 raised to 6 Newton per meter. N is this 180 rpm. T is this 30.2208 into 10 raised to 3 Newton mm. And divided by 60. P is equal to 2 pi 180 rpm multiplied by 30.2208 into 10 raised to 3 Newton meter upon 60 is 569.65 kilowatt. And next step is, second objective is to find maximum shear stress. By using this same torsional formula, T by J is equal to G theta upon L is equal to tau upon R. And objective is this. We have this T also, we have this J also. So use T upon J is equal to tau upon R formula. This tau maximum is equal to T upon J into R. This R maximum. Use R maximum. So T is 30.2208 into 10 raised to 6 Newton mm. Use Newton mm value for solving this tau max, because see, this T is in Newton mm, this R is in mm, and J is in mm raised to 4. So Newton mm divided by mm raised to 4 is this mm, and this 2 mm get cancelled, Newton per mm square. We need this shear stress in Newton per mm square. So that's why use this T is in Newton mm, and Newton mm value is 30.2208 into 10 raised to 6. And maximum diameter is 200, so maximum R is 100. And polar moment of inertia is 92.74 into 10 raised to 6. This 10 raised to 6 get cancelled. So tau maximum is equal to 30.2208 into 100 divided by 92.74 into 30.2208 multiplied by 100 divided by 92.74 into 10 raised to 6 is 10 raised to 6 32.59 Newton per mm square. So this is tau max and this is P in kilowatt. Thank you very much.